The past is gone. It's the most basic assumption of human existence. We treat yesterday like a phantom, a thing that once was, but has now evaporated to make room for the now. We imagine ourselves standing on a razor's edge, where the future is a void yet to be filled, and the past is a graveyard of moments that have ceased to exist. But if you look at the universe through the eyes of Richard Feynman, you realize this intuition is fundamentally, almost hilariously, wrong. The past isn't a memory, it's a coordinate. It hasn't vanished any more than the city you left behind on a cross-country flight has vanished. In the actual mathematical description of reality, the past is a physical, fixed location within the four-dimensional structure of the universe. This is the core spine of modern physics, yet it feels like a direct assault on our sanity. We are used to thinking of time as a river that flows, carrying us from a then to a now. But physics doesn't see a river, it sees a map. In this map, yesterday is just a place you aren't currently standing. Think about it this way. When you travel from New York to Los Angeles, you don't assume New York has ceased to exist simply because you can no longer see it. It remains a valid location in space. Feynman's genius was in realizing that space-time works exactly the same way. This leads us to a massive, haunting core question. If the past is truly a physical coordinate in a four-dimensional structure, why do we feel so helplessly locked out of it? Why are we trapped in this tiny, moving sliver of the present? We are forced to confront the possibility that our deepest feeling, the feeling of time passing, is not a property of the universe at all, but a limitation of our own perspective. We think the past is gone because we can't go back and change it. But in a world where time is a dimension, the past is already part of the permanent architecture. It is woven into the very vacuum of space you are sitting in right now. It never left. It just changed its address in the block universe. To understand why, we have to stop looking at time as a sequence and start looking at it as a geography. In the standard view of reality, we treat the present as a privileged moment, a cosmic spotlight that moves across the timeline, illuminating only one slice of existence at a time. We call this now, and we assume it is universal. But this is the river of time fallacy that modern physics dismantled over a century ago. According to the laws of special relativity, which Feynman applied to the deepest levels of particle physics, there is no such thing as a universal now. Different observers moving at different speeds will disagree on which events are simultaneous. If now is relative, then it cannot be a fundamental feature of the universe. It is merely a subjective marker. This realization forces us into the reality of the block universe. In this model, the universe is not a 3D space that changes over time. It is a static, four-dimensional object. Imagine a giant loaf of bread representing the entirety of space-time. Every slice of that bread is a moment in time. Your birth is at one end, your death is at the other, and every breath you take in between is a slice somewhere in the middle. The crucial point is that the whole loaf exists all at once. The slices don't appear and disappear. They are all equally real, equally solid, and equally present in the four-dimensional structure. When we speak of the past being a location, we are being literal. Last Tuesday is a place in the block universe, just as the corner of 5th and Main is a place in your city. They are both coordinates. The reason this feels so alien is that we cannot perceive the whole loaf. We are like a needle on a record player, convinced that the music only exists where the needle is currently touching. But the grooves for the beginning of the song and the end of the song are already pressed into the vinyl. They are simultaneous from the perspective of the record itself. Our existence is embedded in a structure where every when is just another where. Once you accept that the past is a fixed part of this geometry, you begin to see that the universe doesn't happen, it simply is. While the block universe provides the static stage, it was Feynman who showed how the actors on that stage actually behave. To understand how the past remains active in the present, we have to look at his most profound contribution, the path integral formulation of quantum mechanics. In classical physics, We assume a particle traveling from point A to point B takes a single, predictable route, the shortest path. But Feynman realized that the quantum world is far more chaotic and interconnected. He proposed that a particle doesn't just take one path, it takes every possible path simultaneously. This means that when an electron moves through spacetime, it isn't just moving forward in a straight line. The mathematics of the path integral requires the particle to explore every conceivable detour. It zigzags across the galaxy, it loops around distant stars, and most shockingly, it takes paths that move backward in time. In Feynman's view, the past is not a closed chapter that the particle has left behind. Instead, those backward looping paths are factored into the calculation of where the particle is now. The past is literally reaching forward, interfering with and shaping the present moment. If you remove these backward in time paths from the equations, the math breaks. The predictions no longer match reality. This suggests that the four-dimensional structure of the universe is much more tangled than our daily experience suggests. We think of the past as a solid floor we've already walked over, but at the scale of atoms, the floor is still being walked on in every direction at once. The particle is aware of its entire history because it is physically sampling its own past as it moves. By treating time as a location that can be revisited mathematically, Feynman proved that the past isn't just there, it is an active participant in the physics of the present. This blurring of then and now at the subatomic level is the first hint that our rigid, one-way view of time is nothing more than a macroscopic illusion. This blurring of time becomes even more concrete when we look at one of Feynman's most daring insights: the nature of antimatter. In our everyday world, we see matter as the real stuff and antimatter as its rare, volatile opposite. But Feynman realized that the mathematics of a positron, the antimatter version of an electron, looked suspiciously familiar. He proposed that a positron is not a different kind of particle at all. Instead, a positron is simply an electron moving backward in time. This wasn't just a clever metaphor, it was a functional description of the four-dimensional structure. Imagine a single electron traveling forward, hitting a point in space-time, and then bouncing backward into the past. To us, trapped as we are in a forward-moving perspective, that backward-moving segment looks like a separate particle with an opposite charge, a positron. When the forward electron and the backward electron meet, they seem to annihilate in a flash of energy. But from the perspective of the block universe, nothing has been destroyed. It is just a single path through space-time, making a U-turn. This shatters the misconception that the past is an unreachable void. If antiparticles are essentially past-bound versions of normal matter, then the past is physically present in every high-energy interaction in the universe. It means that the past and future are not directions of travel, but orientations within space-time. We don't see things moving backward in our daily lives, but the machinery of the universe requires this bidirectional flow to function. By identifying the positron as a time-reversed electron, Feynman showed that the past is not a vanished state of being, but a valid direction of motion that particles are taking all the time. The only reason we don't see people or cars doing the same is not because physics forbids it, but because of a massive statistical barrier that keeps our macroscopic world pointed in one direction. If the laws of physics are time symmetric, meaning they work exactly the same, whether a particle moves forward or backward, then we are left staring at the heart of our core question: why is our crush experience so aggressively one way? Why do we remember a shattered glass, but never see the shards spontaneously leap back onto the table to reform? The answer, as Feynman emphasized, isn't found in the fundamental equations of space-time, but in the concept of entropy. Entropy is a measure of disorder, and the second law of thermodynamics states that in any closed system, disorder tends to increase over time. But here is the catch. This is a statistical law, not a fundamental one. There is nothing in the laws of motion that prevents the atoms in a shattered glass from perfectly realigning themselves. It is simply that there are trillions upon trillions of ways for a glass to be broken, and only one very specific way for it to be whole. The arrow of time is not a property of time itself. It is a description of the overwhelming probability that systems move from ordered states to disordered states. Feynman used the analogy of a box of gas molecules. If you start with all the molecules in one corner, they will naturally spread out until they fill the box. This creates a direction from past ordered to future disordered. We perceive this statistical drift as the flow of time, but the individual molecules don't know the difference between forward and backward. They are just colliding according to time-symmetric rules. Our consciousness and our memories are physical processes that rely on this increase in entropy. We remember the past because the process of recording information in our brains creates a trail of disorder behind it. In the block universe, the past hasn't disappeared. We simply perceive a directionality because we are riding the wave of increasing chaos. The past is still a solid location in the four-dimensional structure, but our biological sensors are only tuned to see the transition from order to mess. Once we accept that time is a location and the arrow of time is merely statistical, we have to rethink what it means to be a human being. Our intuition tells us we are three-dimensional creatures sliding through a fourth dimension like a train on a track. We think the US of 5 years ago is gone, replaced by the US of today. But in the block universe, you are not a fleeting point. You are a four-dimensional structure. You are a solid, physical object that stretches from the moment of your birth to the moment of your death. Physicists often describe this as a world line, or more evocatively, a four-dimensional worm. One end of this worm is a crying infant in a hospital bed. The other end is an elderly person taking their final breath. Every version of you that has ever existed, the toddler learning to walk, the teenager experiencing heartbreak, the adult reading these words, exists simultaneously as a part of this massive, extended geometry. You aren't moving through time any more than a mountain is moving through space. The mountain exists from its base to its peak all at once. You exist from 1990 to 2070 all at once. This brings a profound resolution to our core question. Our consciousness is like a flashlight in a dark room, illuminating only one thin slice of this four-dimensional worm at a time. We experience the now not because the other moments aren't real, but because our biological hardware, which is bound by the laws of entropy, can only process information sequentially. We are effectively 4D giants who are only aware of our 3D cross-sections. This perspective shifts the very nature of identity. You are not a spark in the dark that vanishes as soon as the present moment passes. You are a permanent feature of space-time. The you of 10 years ago hasn't been lost to the void. That version of you is still right there, fixed eternally at its specific coordinates in the four-dimensional structure of the cosmos. This permanence of the self is not just a philosophical comfort. It is reinforced by the weirdest phenomenon in physics, quantum entanglement. We usually think of entanglement as a spooky connection across space, where two particles remain ED regardless of the distance between them. But Einstein and Feynman's work suggests that this connection is not restricted to the three dimensions we see. Entanglement also exists across time. In the four-dimensional structure of the universe, a measurement you make right now can be mathematically entangled with a state that existed in the past or will exist in the future. This means the past is not isolated. It is locked to the present through a web of quantum correlations that span the entire block universe. Feynman's path integral approach treats the history of a particle as a unified whole, where every point on its trajectory is dependent on every other point. If the past were truly gone, these correlations would have nothing to hold on to. But because the past remains a valid location, information is never truly deleted from the cosmos. It is preserved in the entanglement of particles and the geometry of space-time. When you look at a distant star, you are seeing light that has traveled for millions of years. That light is a physical bridge between two coordinates in the four-dimensional structure. The event of that star emitting light and the event of your eye absorbing it are connected by a single, continuous chain of causality that exists simultaneously within the block universe. This reveals that the universe has a perfect memory. Every interaction, every collision, and every thought is a permanent record etched into the fabric of reality. We are not just seeing the past. We are interacting with a version of reality that is still there, still real, and still entangled with everything we call now. The present isn't the end of a chain. It's a central node in a vast, four-dimensional web where every moment is permanently lived. The final resolution to our core question, why we feel like the past is a ghost, even though physics says it's a place, comes down to a simple, humbling truth. Our perception is a survival mechanism, not a mirror of reality. We are biological machines designed to navigate a world of cause and effect, of breaking eggs and decaying leaves. This requires a brain that prioritizes the now to ensure our survival. But as Richard Feynman showed us, when we step outside our own skin and look at the universe through the lens of pure physics, the river of time evaporates. What remains is the block universe, a majestic and eternal four-dimensional structure where nothing is ever truly lost. The flow of time is a subjective illusion created by the statistical drift of entropy, a byproduct of our consciousness, scanning through a reality that is already finished. We aren't leaving the past behind. We are simply located at a different point in the geometry of spacetime. This perspective changes the ending of every story. If all moments exist simultaneously, then the people you have lost are still there, at their specific coordinates, as real and as alive as they ever were. Your childhood isn't a fading memory. It is a permanent feature of the cosmos, as solid as a mountain range. Every sunset you've ever seen and every joy you've ever felt is etched forever into the four-dimensional structure of the universe. Feynman didn't just give us equations. He gave us a way to see that we are more than fleeting sparks. We are threads in a tapestry that spans the beginning and the end of time. The past isn't gone, it's home. It is the foundation that supports the slice of reality you are currently experiencing. Once you understand that time is a location, you realize that you aren't traveling away from your life. You are inhabiting it, one eternal coordinate at a time. The universe doesn't forget, and it doesn't delete. It simply exists in its entirety as a single, magnificent, and frozen masterpiece of space-time. The past hasn't left you. It is right where you left it, waiting in the silence of the fourth dimension, part of the permanent and beautiful structure of everything that is.